Welcome everyone to New South Wales DPI Dairies webinar number 8, Robotic Milking for Sustainable Dairy Systems. My name is Nicholas Lyons. I will be your speaker today. I am the Development Officer, Robotic Milking Systems within the New South Wales Department of Primary Industries. This is a national role supporting technology adoption on Australian dairy farms with a particular focus, but not limited, to robotic milking systems. I hold a Bachelor of Ag Science from Argentina and a PhD in Animal Science with robotic milking from the University of Sydney in Australia. I've got over 10 years in public and private organizations related to the dairy industry, working in very close contact to farmers, researchers, and commercial companies to try to drive technology adoption on Australian dairy farms. This presentation is entitled Robotic Milking for Sustainable Dairy Systems, and a bit of a background behind this presentation. I was once at a field day on a farm, and we started talking with a farmer and a consultant about what the future of the dairy industry could look like and what technology in the future of the farms could look like, and how could technology provide an opportunity for sustainability in the dairy industry. So I started trying to give some arguments of why did I think robots were an option for the future of dairy farming, and therefore we kind of ended up, or I ended up concluding that I definitely thought the robots were going to be a big part of the future in the dairy industry, and I ended up phrasing that probably it was better to talk about sustainable dairy systems, because my particular view was that probably robots were going to be a part, or a very big part, or the norm of the future farms. So therefore it's more termed sustainable dairy systems. So I would like to start this presentation talking a bit of the current challenges that dairy farmers and the industry face, not only in Australia but also overseas and in many countries we work with. Every time the herds are bigger, so if we look at Australia, for example, in the last 25 years, the average herd size has increased from around 80 cows to around 240. So that's 3 times the size in the last 25 years. Every time there is more demand or more pressure on those cows, so cows tend to produce more milk, and that puts more pressure on the health, the welfare, and the reproduction of those animals. The farmers are faced with huge pressure for time. So dairying is a quite labor-intensive activity, and if we look only at milking, milking accounts for around 50 to 60% of the time on a dairy farm. So it's a huge pressure to milk more cows, and we're putting a lot of pressure on the staff that have to do those activities on farm. So that's why we are finding very difficult to attract or retain new staff or younger generations to work on farm in the dairy industry, because they don't find it attractive to be tied up to a repetitive task, a routine, long hours of work that make it a lot of times socially incompatible. And also the pressures, the economic pressures for profit are quite high in the dairy industry. So inputs are rising, the price for milk changes throughout years and across the year, and that puts a lot of pressure in the volatility and variability of those costs and prices that the farmers receive that make it challenging or difficult for them to be sustainable as they move into the future. So the big question is, how will farmers and the industry face these challenges, not only now, but also in the future? Will we continue on the same path as we've been doing in the past? Will we continue managing larger herds and putting conventional sheds to milk larger herds in the same way as we've been doing in the past? And I definitely think that probably this is not the best way to move forward. And I definitely think that robotic milking is here to stay. Today we have 42 farmers in Australia that are milking anywhere between 110 cows and 800 cows with robots in pasture-based systems, indoor barns, year-round calving systems, seasonal calving. So there's a quite variety of farms and systems operating with this technology. If we look at more mature markets like the European countries, where robot adoption started in the early 90s, we see that in some countries around 50 to 70% of all new dairy installations are robots. So I definitely think that robotic milking is here to stay. So what can a robot do? Regardless of the brand or type of robot, and we've conducted 2 webinars some months ago that are available online of different type of robots, all of them can identify cows, can clean or prepare teats, can identify or locate that teats and attach the cups. All of them milk quarters individually and record a lot of parameters at an individual quarter level. They're able to spray teats after milking and direct cows to different areas. And also, and most important, all that information, procedures or tasks are recorded and kept online on a computer. So the farmer needs to spend some time monitoring reports, graphs, or values to understand what's happening on farm and monitor what the cows or the herds are doing. So the big question that came in that conversation was, what role will robotic milking have in the sustainability of the dairy systems in the future? And the very first important thing is to define sustainability. According to the World Commission on Environment and Development, they defined in the late 80s that sustainable development, regardless of what type of development it was, meant that it was a development that needed to meet the needs of the present without compromising the ability of future generations to meet their own needs. So it means being able to do today things and taking care of everything that needs to be taken care of for those in the future to be able to do the same. So when we look at the dairy industry, we've commonly named 3 pillars for sustainability, or the triple bottom line that define sustainability. And I've added a 4th pillar just because I think it needs a differentiation for robotic milking. So the first one that is a bit different to that traditional triple bottom line is the cow itself, or the production of the system. The second one is the environment in which that system operates. The third one is a labor or social aspect to these systems. And the 4th one is an economic sustainability aspect to these operations. So now we'll try to cover these 4 pillars and how robotic milking affects those 4 pillars. From a production or cow point of view, the first question that many farmers or consultants ask is, do robots offer a possibility to milk cows more frequently and therefore obtain an increase in milk production? Definitely robots offer the possibility to move away from the conventional twice-a-day milking and milk cows more often. But that does not always translate to an increase in milk production. When we look at the literature reports between a 2 to 12% increase in production compared to twice-a-day milking, but also they mention that many farmers, when they transition from conventional to robotic milking, they change a lot of things in the system. So they cannot always attribute this increase in production only to the robots. Some literature reports between a 0 and 15% drop of milk production in the first year, and farmers looking to move into this technology need to take this into account when considering or making budgets. And we've seen that the farmers that have a lower drop in milk production or recover quickly are those that do the recommended homework. So they know what they're getting into, they visit operating farms, they know how to prepare the farm, the staff, the layout, and the cows to what is coming, and they are prepared for this change in managing the whole system and therefore minimize the loss. We've also seen that heifers do not always respond to an increase in milking frequency, so therefore it's probably not needed to milk heifers more frequently. And we also see that there is a variability in milking frequency both within and between cows. When we try to see what happened in the Australian context, DPI and I manage a project that now is called the International AMS KPI Project, in which we are monitoring 19 farms throughout the world, 12 of them in Australia, 2 in New Zealand, 4 in Ireland, and 1 in Chile, and we monitor them on a monthly basis to see how they are performing. This is the second phase of a project that started in 2015 that was called the Australian AMS KPI project, where we were monitoring 9 Australian farms on a monthly basis. And these results on the screen are a reflection of that Australian AMS KPI project. The first thing that we saw was that there was a wide range in results that could be achieved on farm. So there were not two farms that obtained the same thing, and this depended on the farm aims and how they managed the system. But in general, we saw that yes, they achieved a higher milking frequency that sat on average in 2.3 milkings per cow per day. And that was quite stable within farm, but it changed between farms. Then we saw that these farmers reported 45% of them reported an increase in production compared to when they were milking conventionally, and that increase was around 5%. This was anecdotal evidence, but they reported that. And the average milk production during those 12 months of those 9 farms was 24.1 kilograms per cow per day of those cows that were milked 2.3 times per day. Then we saw that they had a better health of the cows and milk quality. And we saw that on average, the somatic cell count of cows milked of these 9 farms was around 205,000 somatic cell count per milliliter. So it was possible to achieve a higher milking frequency, a good or higher milk yield, and a very good quality of milk. The other important thing to consider with robots is the milking or cow traffic is voluntary. So we do not rely on operators going to the paddock and fetching the cows twice a day. Cows move voluntarily to and from the dairy. And this cow traffic, or this voluntary cow traffic, is based on incentives, being feed the number one incentive to encourage cows to move to and from the dairy. So what we saw is that these systems and cows moving voluntarily on their own from the dairy had a benefit from the production and welfare point of view. And these figures are from Australia, the ones that you see on the screen at this time. We are able to manage cows individually because you can have cows in early lactation milking 2.3, 2.5 times per day, and cows in early lactation milking 1.2, 2 times a day. So you can manage cows individually, and cows that have different requirements can have different milking frequency or different allocation of concentrates or whatever. Then the fact that we can attach cups at a quarter level and monitor and milk them at a quarter level reduces the incidence of over milking. Because once a quarter finishes milking, you can remove the cup from that quarter and continue milking the rest of the quarters. So I think this has 2 great benefits that are reflected in the figures below. 50% of the farmers say that with robots they have improved the milk quality, and 50% of them say that they've stayed the same. And this is very important because I think that robots only harvest milk and enable the operators to achieve a lot of things, but it is management that will determine what farmers achieve. So they achieve a higher milk quality probably because they reduce the over milking of the quarters, and they're able to do the consistent milking routine every day of the year and every milking in the same way. It doesn't depend if the operator turns up to milk on time, if it's raining, if he wants to milk faster or whatever. All the procedures take place in the same way every day of the year. And cows just love this consistency. Then 45% of the farmers say that they see an improvement in udder health, whereas 18% of them say that they've seen a decrease in udder health. And this is completely possible because, as I said before, robots only harvest milk and management is very important. We tend to see a decrease in udder health soon after commissioning because the farmer is learning how to manage the system and learning how to manage cow traffic. There was research done within Future Dairy that they determined that cows that present themselves to be milked with intervals over 16 hours, so that is 16 hours between 2 consecutive milkings, tended to have a higher risk of mastitis and a lower proportional milk yield. So if we cannot manage the incidence of high milking intervals or long milking intervals that can have a negative impact in udder health and milk production. And these things are or occur more frequently soon after commissioning till the farmer, the cows, and everybody learns how to manage the system. 92% of the farmers say that they've seen a decrease and a dramatic decrease in the incidence of lameness. Because I think that the fact that cows are moving at their own pace, walking themselves to the dairy and nobody's pushing them, has a dramatic incidence in the amount of lameness on farm. From studies done with a PhD student by a PhD student at Sydney University on conventional dairy farms, he monitored many farms in New South Wales, and he saw that some of the two factors that caused a higher incidence in lameness were, number one, herding cows to the dairy. So people herding large herds or herds twice a day to the dairy, generally they pushed herds in the laneway, and that caused an increase in lameness. In robotic milking, as cows are moving voluntarily, this is reduced, and therefore that's why we think lameness is reduced. And the second thing that caused lameness was cows standing on concrete for a long time. So we tend to see that cows should not spend more than 1 hour, ideally more than 2 hours, definitely standing on concrete. And what we see is that as cows have increased in herd size and the dairy shed has not always kept up to speed with that increase in herd size, the milking takes longer and cows spend much longer standing on concrete. So therefore, in a robotic milking system, as cows walk on their own and they do not always stand in a queue, because this offers the possibility of cows not standing in a queue, arriving in the dairy, getting milked and leaving, we see that the amount of time they spend in concrete gets dramatically reduced, which we believe has a strong impact on reducing the amount of lameness in the herd. And 91% of farmers have said that they've increased their heat detection. And again, we think that by being able for the cows to move at their own pace and show more natural behaviors, it's easier for operators to detect cows on heat. But also, to be fair, a lot of the systems or the farmers that decide to install robots buy the robots with the technology to detect heat. So that is through either activity or rumination or a combination of factors that help the farmer detect which cows are about to become on heat or are on heat. Also, they've reported that cows that are on heat or about to become on heat are the ones that remain behind in the paddock and require fetching, so it's easier to find these cows. So that's why we think there is an increase in the heat detection. It is also very important to understand that with robotic milking, we need to work with the cow. I think dairy farmers have become too accustomed to pushing and locking cows up. We've got used to going to the paddock twice a day, fetching cows, pushing them to the dairy, locking them up in the waiting yard, pushing them through the dairy shed, locking them up in a feed pad, pushing them back to the paddock, and locking them up in the paddock, and repeating this twice a day, every day of the year. With this, we require the cows to move at their own pace and move to the dairy and back to the paddock, and this requires working with the cow. So one thing one farmer told me once was that farmers struggle to understand cow behavior, and we've done a webinar in the past with Joop Driessen from Cow Signals to try to understand cow behavior, because farmers struggle to understand why cows are doing what they are doing and why cows are not doing what they want them to do. So it's very important to start to understand that we need to work with the cow. So this slide that is in the screen at the moment shows two studies conducted by a PhD student at Future Dairy Sydney University, Miss Ashley Wildridge. She did one trial where she put shade in different points of the laneway, and she tried to see what was the impact of providing shade to the herd on cow traffic. And she saw that providing shade at different points in the laneway encouraged or improved cow traffic and improved animal welfare. So this is an improvement that we can influence cow behavior, but that cows respond to this cow behavior. So we need to see how do we move or encourage cow traffic. The bottom part of the screen shows a second trial by Ashley, where she split the herd in two and provided her half of the herd access to shade in the pre-milking waiting yard, and half of the shed did not have access to shade in the pre-milking waiting yard. And she saw that the cows that had access to shade in the pre-milking waiting yard had an improved respiration rate, so better animal welfare, increased concentrate consumption because they did not have a heat stress, and we see there's a negative impact of heat stress on intake, and they also improved milk production. So by influencing conditions on the farm, we can improve cow welfare or production. A third study that Ashley conducted was trying to understand how cow behavior changed before and after commissioning robots. So she visited 5 commercial farms in Australia before commissioning AMS, and then 1 year after that to understand the comparison of how those cows behaved after commissioning AMS. And what she noted was 3 things. With robots, cows spent less time in direct contact with cows. Farmers spend less time in direct contact with cows. So they did not see all the cows twice a day. They only saw the cows that needed attention. So those that in reports needed to be drafted and looked at, or those cows that were fetched, or those cows that were in the yard when the operator turned up. But they did not see 100% of the herd twice a day. And that is not necessarily a problem, because now you're starting to see the cows that really require attention. The cow that is doing what she needs to do and moves and does everything that needs to be done, you do not see her, but probably you do not need to see her either. Then she noticed that cows had a much shorter flight distance. And flight distance is determined by the distance that cows allow people to get close to them before moving. So for example, there is 10 meters between you and the cow is grazing. If you step a step further, you're 9 meters close to the cow still is grazing. If you make another step and now you're 8 meters close to the cow and the cow moves, it means that that cow has a flight distance of 8 meters because she does not allow you to get closer than 8 meters to her. So what we saw is that cows on robot farms, or after commissioning robots, had a shorter flight distance, so they allowed the operators to get much closer than before. And we think that this is related to the third factor, that is that they have less stress. So they lose fear of operators and they start allowing operators to interact with them in a different way. So my question is, probably with robots, we are able to keep cows for longer in the herd. This slide here, or these numbers, are from a paper that came out from De Laval Cow Longevity Conference in 2013 in Sweden, where Charlotte Hallén Sandgren presented some figures of the replacement rates or culling reasons at an international level. She showed that 35 to 40% of the cows were replaced annually on a dairy farm. That 70 to 80% of the involuntary culling was due to health or fertility reasons, and the health reasons were either mastitis or lameness. And that 50 to 30% of the cows that left the herd did so within the 2 first months of lactation. So these are international figures, and for example, if we look at the replacement rates in Australia, it's probably around 25 to 35% on average. There's a huge opportunity here to reduce this. And we think that what I've mentioned before, or what I try to show you, tries to address this. So there's a lower incidence of mastitis, a better udder health, a reduction in lameness, an improvement in heat detection. And by monitoring the cow and having all these records in the computer, we can probably manage the herd individually and keep cows for longer. So having a replacement rate of 30%, 35% means that we keep cows on the herd only for less than 3 lactations on average. Just imagine what could that mean for a farmer or the industry if we could keep cows for 4 lactations or more on average. So I think robots have a huge opportunity here to increase the sustainability of the farm and the industry by keeping cows longer. The other aspect of production is the feed. Pasture management is key because, as I said before, having voluntary cow movement requires to manage that incentive, and feed, as I said before, was the incentive number one that works on almost all the cows all year round. So managing feed is key. And as a large proportion of farmers in Australia are pasture-based, managing pasture and pasture allocation is key to achieve those cow traffic targets. And what we saw from research done by Future Dairy and published by Cameron Clark in 2015 was that there was, within this farm located in New South Wales, there was two dairies side by side, a conventional dairy and a robotic dairy. Applying the same exact principles of management of pasture, those two farms achieved exactly the same pasture utilization. So both of them harvested 13.5 tons of dry matter per hectare. So you can apply the same principles and achieve exactly the same utilization with conventional or robotic milking. But when we look at that, what they achieve in utilization, that's more than double than the national average in Australia. The national average of pasture utilization is somewhere around 6 tons of dry matter per hectare. So therefore, it's not surprising that many farmers that transition to robots believe they are now growing and utilizing much more pasture. And this is probably related to two things. One is they do not require to milk cows twice a day. That time becomes available to do other things. So now they can spend more time focusing on reproduction, health, general management of the business, taking better decisions, but definitely managing and allocating pasture, because that has a straight or direct impact on cow traffic. So now they start paying attention to this. So I think that by paying more attention to pasture allocation, they see or they perceive an improvement in pasture growth or utilization. So that was related to the cow or the production. The second pillar of sustainability is around the environment. And I think that robotic milking has a strong impact here, because if you look at that screen, that slide that you see on your screen at the moment, on the left you can see an aerial view of a robotic farm in Tasmania that is split into 3 areas. So now robotic farms do not manage 100% of the herd in a morning allocation that then move to an afternoon allocation. Now there is traditionally 3 allocations available to cows within a 24-hour period. Is what we call 3-way grazing or ABC grazing. And there will be a webinar in the future trying to cover this pasture allocation. But cows move or are offered access to 3 allocations of feed within a 24-hour period. So now they move around this area and they come to the dairy at different times of the day. So if you look to the right, that is a schematic layout of a robotic farm in New Zealand that has 2 robots in those 2 rectangular boxes on the right, and the other rest is the waiting yard. So you have the access from the 3 layouts, grass 1, 2, 3, and the herd comes to the dairy. But as now you do not have 100% of the herd coming to the dairy, you do not need a pre-milking waiting yard as big, because you're never moving cows in the lane where 100% of the cows, and you're never having 100% of the cows in the dairy at the same time. So this means that you can potentially reduce the amount of floor surface in the dairy by up to 75%. So this means less concrete, so it's a lower investment cost, but also less surface to collect and manage water and effluents. So this means that the amount of effluents that are collected are lower. Also, anecdotally, what we see is, or what we think we see is that in a conventional dairy, the amount of effluents that are deposited in different areas of the farm are directly related to the amount of time that the cows spend on that area. So if they spend a third of the day in the paddock, a third of the day in the laneways walking to and from the dairy, and a third of the day in the dairy, there will be a third of effluent, that is manure and urine, collected in each of those places. In a robotic dairy, cows move at their own pace, and they spend a different allocation of time in different areas. So what we think, and there's now a student that is going to start looking into that, is that there's going to be much more effluent in the paddock and distributed in 3 areas per day, as you can see in that layout on the left, and less effluent on the laneways because they're all walking at their own speed, and much less effluent in the dairy because they're not waiting as long and there's not many cows all together in the dairy. So that is another huge opportunity for robotic milking. The other one is cow laneways. A lot of the farms that install robots are transitioning from conventional dairy to robotic milking, so they do not have the possibility of changing the laneways. But if you're in a greenfield and you need to install and plan the laneways, you do not require very long, very wide laneways. There you have on the picture of the left, both pictures are from Ireland, but the picture on the left shows the 3 laneways from the dairy for paddock A, B, and C. Look at the width of the laneway. You do not require 6 meters, you can do it with 2. Look at the one on the right. That's slightly over a meter because the cows are walking in a single file to and from the dairy. So at most you would need space for 2 cows to walk to and from the dairy. They almost walk like sheep in these systems. The other aspect of robotic milking that is impacted is energy consumption. Back in, I think it was 2015, we had the comment of farmers that they had a higher energy consumption with robots in Australia. So what we did together with Dairy Australia, the industry organization, was to conduct energy audits on 12 Australian robotic farms. And what we found was that there was an increase in 50% of energy consumption in robotic milking. So whereas the average of conventional dairies had 50 kilowatts hour per 1,000 liters, the average of the robotic farm was around 75 kilowatt hour per 1,000 liters. So yes, there was an increase, but there was also a huge variability between farms. So some farms were very efficient, some farms were very inefficient. When we look at the top 3 things that were consuming energy in the farm, we saw that they were the same for conventional and robotic milking: milk harvesting, cooling, and water heating. And if you look at that graph on the bottom right, you see how the energy consumption is distributed between robotic milking in blue and conventional milking in orange. There was a much higher consumption in milk harvesting, that is the center, the middle 2 bars, and much higher for robotic milking in comparison to conventional milking, and that is related to the air compressors and the vacuum pumps having a higher energy consumption and operating for 24 hours a day. But there was a very similar consumption for milk cooling because the amount of milk did not change, but there was a lower consumption for water heating because now you did not require to wash as many units or a big plant as you did before. But the other conclusion was that there was old and oversized equipment for AMS. So most of the farms were bringing along the equipment that they had for the conventional milking to robotic milking, and this was not right. So that equipment was old and oversized for the requirements of AMS. So the main difference was that robotic milkings operate for 24 hours a day, whereas conventional milking operates at 2 discrete milking sessions a day, and they are smaller, so they require, for example, in milk cooling, they had a similar requirement for milk cooling, but they were oversized because whereas conventional milking required to cool down large volumes of milk quickly after the milking session was ended, robotic milking required to cool lower, smaller volumes of milk, but constant throughout the whole day. So this is a completely different requirement of energy. So the equipment was not sized or dimensioned for the conditions of robotic milking. The other one was water heating. For conventional milking, you required to wash, let's say you had a 12 or 14 herringbone, you required to wash that 12, 14 units twice a day. Whereas with robotic milking, you could do probably the same with 2 or 3 robots for the same herd size, so you will need to clean 2 or 3 units. So there was a lower amount of water needed, which is also supporting the environmental aspect, but also as you needed less water, you needed to heat up less water, sorry, so that you didn't require the same amount of water heating. So there was a great potential to reduce the energy consumption and cost. And one of the conclusions was that robotic milking was very well suited to renewable energy sources, but only one farmer in Australia at that time was using renewable energy sources, and this is an article that came out of that farmer in the Australian Dairy Farmer in late March 2017. He operates, or he's got solar and wind renewable energy sources. He captures the energy with those sources, he stores them in battery, and then depending the time of the year or the time of the day, he can supply the whole energy requirements just with these renewable energy sources. So one of the conclusions was farmers should start thinking about this, because again, it's lower requirements but spread throughout the whole day. So start thinking about this from some farmers. So I already know that there's at least 3 other farmers in Australia that have invested in some sort of renewable energy sources. So that was the cow, or the production aspect, number 1 of sustainability and the environment point of view. The third pillar of sustainability was the social. And the big thing was, do robots have a positive impact on the social aspect? When we look at the literature from Europe, there's around 20 to 30% reported labor savings, up to some people that report no total change in the total labor requirement, but yes, a shift in the labor use, or how the labor was used. So in 2014, there was a technical person within Future Dairy, Juan Molfino, that did labor audit on 5 commercial farms in Australia, where he audited them on a monthly basis for a whole year. And he found a 54% increase in labor efficiency. So those have been published as labor case studies that are available on Future Dairy's website, and you can access them to find out how they operate. But in a nutshell, this is the 5 farms and different things from those farms. Look at the second last line. Look at the amount of cows per full-time equivalent that they are managing, between 100 and 273. When we compare that to the regional average that corresponds to conventional dairies in that same region, so the farmers were across different regions, we see that there's an improvement of on average 54%. So you can manage labor in a different way, and different farmers will capture the labor savings in different ways. Some farmers might not reduce the total labor, but allocate that labor in a different way. Some farmers might be able to reduce the labor on farm. Some farmers might choose to milk much more cows with the same amount of labor. So different farmers will capture those benefits in different ways. So the question is always, do I think robotics will replace labor? I think it really depends. And probably I don't think it will replace labor, but it will definitely make labor work in a different way, and hopefully in a better way. Why? Because on average, the farmers in Australia have said that 40% of them see a decrease in the amount of hours worked, 20% stay the same, and 40% increase. So basically what you're doing is replacing a manual task of twice a day milking cows, and that task taking 50 to 60% of the time on farm on a daily basis, to monitoring and managing the whole business. So you can free up that time to do other tasks. And that's why I think they become better. There's better health, better reproduction, better production of cows and pasture, because you're shifting that labor to do other tasks. But the other important thing is that 60% of the operators said that they had an increase in the facility to attract and retain external labor. And I think this is very important from the sustainability point of view of the whole industry, because tasks will change. Robotics won't change or replace labor, but there's still a lot of tasks that need to be done. Robots at least currently, cannot allocate pasture, cannot fetch calves, cannot fetch a small proportion of cows that require fetching because they do not volunteer, cannot change filters, cannot wash yards, cannot allocate supplements. So I think there's a lot of things that still need to be done on farm. But if we look at particularly the Australian conditions, in Australia, 98% of the dairies are family owned. 83% of the dairy farms are owner operated, and 35% of the farmers do not employ external labor. So I think it's not a minor thing if you're going to increase the possibility to attract and retain labor and have probably higher skilled labor employed on farm, or at least a lower rotation of the farm staff. So I think this is a very important aspect from the social sustainability point of view. The other social aspect that I think is completely untapped nowadays is the whole traceability. Robots offer the possibility to manage cows individually and record a lot of things individually, to milk cows individually and record what's happening at a quarter level, and to have all these records on the computer. So I think there's a huge potential to monitor and record absolutely everything at a quarter, milking, and cow level. And I think this will be quite appealing to many consumers if we can tell and track a story of food production from the paddock to the plate. I think this is very strong and very powerful, not only from the health and point of view of tracing this food produced, but also from a business point of view. We can show people we keep track of what is happening to the milk that you consume, but also to the cows where that milk is being produced. So I think this is a huge opportunity that not many farmers are tapping into. And the fourth pillar of sustainability is an economic point of view. And the big question is, yes, robots are a big investment. How can I justify them? What's the economic benefit of adopting robots? So this is one farm that did some economic analysis probably 2 or 3 years ago. And those figures of the AMS farm are in the first column, and in the third column is the average AMS farm. Look at where the difference of that farm is. Or how do they split the cost for those farms? Whoops, sorry. There's a very similar income, but look at the herd costs. The herd costs are reduced almost to a third, and that is better health, better reproduction, lower replacement rates. Look at the shed costs. Yes, they do increase, and almost by double, because you have higher energy cost probably, as the energy audits mentioned, and there is reasons that explain it and ways that could be reduced, but there's also a higher repair and maintenance, but not because there's only higher repairs and maintenance, also probably because not many of the conventional sheds are doing the recommended repairs and maintenance. So you're not always comparing apples with apples, but on average, yes, repairs and maintenance goes up, but look at the labor costs, they're also reduced. So I think this will depend on a farm situation, and I would encourage any farm that is looking at any technology to start putting the numbers and analyzing what's happening for their own particular conditions. So there's a very good program at an industry base in Australia called Dairy Base, and farmers are able to put the numbers in and compare or benchmark against different things. We've also now just finished collecting financial and economic information on 9 farms in Australia of robotic farms. So we are currently analyzing that, and that will provide the industry with more information of how those farms are performing and how are the whole cost, income, financial structures being changed with robots in comparison to conventional dairies. But the big question is, do I think, or does the industry think, that robots are profitable? So I split that question in two. If I look at the farmers that are milking with robots, there's currently 42 farmers, 9 of them, so that is almost 25% of them, have increased the amount of robots or cows since they originally commissioned. So let's say they started with 2 robots and 110, 120 cows. Now they have 3 robots and 180, 200 cows. So they've increased the robots. And 72% of the farmers surveyed in Australia that are milking with robots would consider expanding in the next 5 years. So this tells me that, yes, I do not know exactly who those farmers are and the whole financial thing behind them, but I'm sure there is some element of financial profitability that would make them confident to expand the adoption of robots. And then I look at the rest of the industry, and we did a survey back in 2015, and results are being published. But 60% of the farmers in Australia think that by 2025, robots will be the fourth technology that would have an increased adoption in Australia. So the first one was technology to detect cows on heat. The second one was sorting or drafting gates. The third one was elements of technology to manage and monitor milk quality. The fourth one was robotic milking. And the fifth one was technology to measure milk production. So robots is high up there in the list. But the other important thing to me is that robots can do, in most of the cases, sorry, all the other things. So you can keep the activity of the cows, you can sort cows, you can measure things at a quarter level, you can record production. So it enables farmers to manage things differently. In the same survey, we asked farmers if they would consider robots, and 72% of them say that they would consider robots as an option if today they had to install a new dairy. So this does not tell me that they would definitely install robots, but they would at least consider it. And I think that is very important. Robots are a proven technology and robots can work. There's 42 farmers doing it in Australia, more than almost 30,000 farms all around the world with different scale, different systems, pasture-based, indoors, small herds, large herds, family-owned, corporate, that are milking with robots. So they are an option for you to consider. And is there still potential for robots? Sorry, I think definitely there is. In that Australian KPI project that I showed you, the milking frequency, yield, and udder health at the beginning, we monitored how cows traffic to the dairy. So this is, in this graph, the hours of the day, and on the vertical graph, the number of milkings per robot. So this shows how many milkings are the robots performing across the day, and is a reflection of how cows are coming to the dairy to get milked. And it shows that in early hours of the day, let's say around 4 a.m., the robots are performing 1 milking per day, 1 to 2 milkings, per hour, whereas in the afternoon, 6 o'clock in the afternoon, they're performing 7, 8. So let's say we could potentially manage cow traffic and make cows come all throughout the day and achieve 8 milkings, 7, 8 milkings throughout the whole day. We have the potential to increase the number of milkings, cows, or liters that a robot can harvest or manage by up to 60%. So this is a huge potential that farmers could tap into, and that as research and development organizations in Australia, we need to see how do we help farmers to achieve this, because this would bring the investment costs down. Because what would this mean for the average farmer in Australia? The average farmer in Australia today is investing in 4 robots for their 200 to 120 cows. They could do the same with 3 robots. This would be reducing the investment cost by 25%. So I think this is a huge potential that we need to consider. So as a conclusion, I definitely think robotic milking is here to stay. I think the first robot that milked cows was in 1992 in the Netherlands. The first robot that milked cows in Australia was in 2001. It is not a new technology. Farmers are looking at this technology, and this technology is here to stay. The technology has an impact on the whole system, so it has an impact on the cow, on the farmer, on the environment, and on the industry. So we need to see how the technology impacts this and how do we manage it. Farmers and the industry need to be prepared for a great change, and we need to see how do we support, and that is a very big part of my role, the industry and the farmers, to prepare for this great change and be successful in the adoption of this technology. Management is key because, as I said before, robots only harvest milk. The farmer needs to manage the system, so we need to see how do we manage to be able to achieve very good results. And definitely, I think, going back to this main webinar, that robots can have a positive impact on sustainability. Why? Because if we put robots in the center, the robots can address factors of the cow and the production. They can address factors of the environment and the system. They can achieve and address social or labor aspects, and they can target economic benefits. We still have to work a bit in the economic aspects, but they can definitely address these four. So I hope this webinar has um, addressed some of the concerns. I've seen many questions come through the chat box or the question box. I hopefully have addressed most of them. But if there's any question, please let me know, and I will try to address it. So feel free to add questions on your chat box now. I will unmute all of you. If anybody wants to speak up and ask a question or make a comment, please feel free. Okay, I cannot see any question. So I want to thank you very much, all of you, for joining. I hope this has been an informative webinar. I would like to point you to two resources that we manage. I manage and coordinate the New South Wales DPI Dairy Facebook page. So there's more than 700 people from all around the world, and we share regular updates on smart farming and technology. Feel free to follow and like that page. It's very valuable information of general information, but a lot of the things and activities or resources we provide. There's also a New South Wales DBI Dairy Automatic Milking Systems newsletter that has more than 400 subscribers. Again, farmer and service providers from all around the world. That goes out 3 times a year. The next edition is in May. So please feel free to tap into that and follow what we are doing, because there are excellent resources that are available to you. So as with all our webinars, this webinar has been recorded and will become available on the New South Wales DBI Dairy website. So here on the screen, you will be able to see the link. I would encourage all of you to visit the New South Wales Department of Primary Industries website, where you will be able to access tools and resources about the dairy industry. In there, there's a specific section on robotic milking system, and that link on your screen is that specific section that includes a lot of information, not only on robotic milking, but also on precision dairy farming. So once again, thank you very much for joining today, and hope to see you next time on our next webinar. Thank you very much. Bye.